Let's first talk about the linear equation parent function. He is y equals x. I'm going to get some paper and write down a few notes that you need to have written down as well. Y equals x is the equation that describes the linear parent function. And who is he and what does he do? Well, the linear parent function is the parent, the boss of all lines. How do I know that? Because what's inside of the word linear is line. And if you remember me in class, struck a pose. And remember, we stretched our arms out like my hand is stretched out to make a line. And we even turned it the opposite way so that we could see the different types of lines. Well, the parent function is always positive, will always go through 0, 0. And because y equals x, when x is negative 2, y is negative 2. When x is negative 1, y is negative 1. When x is 0, y is 0. That's why it goes through 0, 0. When x is 1, y is 1. When x is 2, y is 2. In other words, these ordered pairs must be on the graph. So here is 1, 1, 2, 2, 3, 3. Here is negative 1, negative 1, negative 2, negative 2, and so on and so forth. When I connect those dots, I have the parent function. Now, we take the parent function, we find the domain and range of it. I ask myself, is there a stopping and starting point for the domain? Meaning x values, I have to cross the x-axis. No, because I have arrows going to infinity, positive infinity. Arrow is going to negative infinity. That means the domain is all real numbers. And of course we know we will see this symbol later on. But on the test it's going to say the words, all real numbers. For the range, do I have a stopping and starting point? Crossing the y-axis, because range represents y values. And the answer is no, I do not have a stopping and starting point, because the arrows keep going up and down. So it's all real numbers again. All real numbers. Okay, so now we're going to take this information and answer the first 3 questions. Which below is the parent function? Well, parent function for linear equations, and that's the word that's not written in the question, but we were talking about linear equations. So this is asking for the linear parent function. That would have to be, well, this is not a line. That's a rational function. That's quadratic. That's a parabola. I need a line. So I have 2 lines. They both go through 0, 0. Well, I take that back. It looks like that is negative 2. And that is negative 2 down there. And 0 is right there. So that leaves me with no choice. It has to be A. Even if this went through 0, 0, it is not positive. That's a negative slope. So that's not it. The parent function can only be the positive line that goes through 0, 0 that has the coordinates y equals x. 1, 1, 2, 2, negative 1, negative 1, negative 2, negative 2, and so on and so forth. The domain and range for linear functions will always be all real numbers. The domain for this parabola, I have a stopping and starting. No, we do not, because we have arrows. So the domain for quadratics will always be all real numbers. Now the range will change. Because there are minimums and maximums, you have to start at that minimum and maximum. So I'm at a minimum for this parabola. And this is my starting point. The ending point, it doesn't end, it continues to go up. So where do I start at? 0. So y is greater than or equal to 0. What did we learn about the parent function? It's y equals x. It is the boss of all functions, meaning this graph right here would be a child of this parent, because the parent has this child, and this child has similar traits. So he looks like him. He's just negative, and he doesn't go through 0, 0. He goes through negative 2 on the x-axis and negative 2 on the y-axis. His domain range is all real numbers as well. So what else did we learn about the parent function? The parent function has children, and the children would be any equation that gives you a line. So this one, for instance, or any other one, we could do negative 2x, we could do negative 2x minus 2. I mean, there are a number of things. You could have said y equals 1/2 x plus 1. All of those are children, because when you graph them, they will all give you lines. Okay, which of the following representations of the linear parent function is not true? Well, does the parent function appear in quadrant 1 and 3? Let's check. 1, 2, 3, 4. So it does appear in 1 and 3. Okay, are these the points on the line? Well, 1, 1, they're the same. 0, 0, they're the same. They're not the same. So this looks like this is the answer. Let me check C and D. 3x minus 5 has y equals x as the parent function. Well, of course, this gives you a line. So this is the child, and this is his parent. So that's true. A graph, the linear parent function is the graph that has a domain and range as all real numbers and can be represented by y equals x. Well, of course, we know it's always all real numbers for linear functions and for the linear parent function. The set of ordered pairs below represent some points on the graph of function f. So this is calling this a function, and the name of the function is f. So in order to know who his parent is, we need to graph. So we're going to graph as many points of these points listed as possible. So negative 1, 3, 5, 15, look like I need more room, 11, 12, 13, 14, 15, and it is 5, 15, negative 4, negative 3, so negative 4, negative 3, negative 7, negative 9, negative 7, negative 9, and 3, 11. So 3, 11. And remember, you always want to use a straight edge when you are connecting a linear equation, and I can tell that this is going to give me a line. It is a linear equation, so I'm going to use a straight edge. And so as you can see, I'll try to use a straight edge off of the paper. Maybe I should have used the book. As you can see here, this is a linear graph. So the parent would have to be y equals x. Y equals x squared looks like the parabola, the quadratic. You don't know anything about square root of x, but it looks like that. It looks like that going through 0, 0. It's the parabola on the side. This is exponential, and it looks like, let's see, more so like this, it shoots up. It's better. Okay. So now we've done the first 3 problems. Let's go ahead and try to finish some questions on steepness and slope, and then we'll go to the next video. Here it says, which line is steeper? Well, you should know that I am steeper the steepness is measured by the slope. So that's m. Whenever m gets larger, the line gets steeper. And you have to remember, I'm talking about the absolute value. So that means if, well, first let's answer this question. Y equals 3x plus 4, and 3 is positive. 3 is my slope, and so I need a bigger number, a bigger slope, which would have to be b. Now I want to change this up, and I want to make this negative 3. And then I want to make this negative 7. Whenever your slope is negative, take the absolute value of it. That means make it positive. So instead of looking at slope as negative 3, you would just pay attention to the positive version of that 3. And then you would find the positive version of each slope that would be larger than this. And so if I ignore the negative on the 7, 7 is larger than 3, b would still be the answer. So when you're talking about steepness and slope, it is the larger number after you ignore the negative, so the absolute value. Two functions are given below, f of x and g of x. How does the graph of f compare to the graph of g? So you should know that when you have the same slope, you have parallel lines. Excuse me. If you happen to forget that, just graph them. So control doc add a graph. And negative 4x plus 1, negative 4x plus 1 divided by 2. And I can see it, and they're really close. So I'm going to zoom out so I can see, or maybe zoom in. I apologize. There we go. And as you can see, they are parallel. So if these numbers were different, I knew I could decide that it would be steepness. But these numbers, the slope, they are the same. So the steepness did not change. The y-intercept is here, b. And the y-intercepts are not the same. So they have to be parallel, which is what the calculator said. Find the slope of a line that passes through these 2 points. So you should know the slope formula. y2 minus y1 over x2 minus x1. And then plug in, okay, you can see the formula now. Okay, plug in 31 minus 17 over 14 minus 10. And get your answer. And whatever this answer is your slope. Or, because that's the slope formula. Or you can do mu 613. So I'm going to add a calculator, go to menu, go down to statistics, go to stat calculations, and then go to linear regression. Okay, and now I'm going to type in the x values only. So I need 10 and 14. So control right parentheses, and the reason I hit the right parentheses is to get the squiggly lines. Okay, 10 comma 14. Make sure that's what I needed. 10, 14, and now I have to put 17 first for the y. 17 comma 31. Okay, enter, and it gives me 3.5 and then negative 18. So my slope is 3.5 and my y-intercept is negative 18. I hit menu 2 to make this turn into a fraction, and it gives me this fraction version of it. So my slope is 7 over 2. That's all this question asked for, or 3.5, whichever one. If it asked for the equation of the line, the answer would have been 3.5x minus 18. Or you could put 7 over 2 in the m spot. But it asked for the slope. That's the answer. If 2k, comma k, and 3k, comma 4k are 2 points on the graph of a line, and k is not equal to 0, what is the slope of the line? Well, you can just take the coefficients and use mu 3, 2, or the slope formula to get to your slope. So I'm just going to use the slope formula since I didn't use it on the last one. If you want to use menu 613, then do it. Remember, you have to know when to use that on the test. I cannot tell you. You have to know when to use that. But the slope formula by hand is going to give me 4 minus 1 over 3 minus 2, which is 3 over 1, excuse me. And 3 over 1 is 3, which is A. But if you had used menu 613, like I did on this one, you would have also gotten 3. If you decide to do this method on the test, please use menu 613 to check your work. I don't want you to make simple mistakes and miss the question. Okay, we're still talking about slope, and it asks which statement is true. I notice that all my answer choices give me a point on the line. And so it says 0, 2. And I know some of you have trouble knowing which one is 2, 0, 2, and which one is 2, 0. Well, the 2 is in the y spot, so that's on the y-axis. So this is 0, 2. Also remember, whenever you're talking about the x-intercepts, you're going to have the 2 in the other spot, which means it would be on the x-axis. Well, if you notice, this one has the 2 in the y spot, so we're talking about the y-intercepts, which are on the y-axis. So 0, 2 is on the line. So this is a possible answer. This is 2, 0, and it is not on the line. That's because the 2 is in the x spot. That's an x-intercept. So for x-intercepts, make a side note. You will see where it is placed on the x-axis in this spot. Meaning, when you see the 0 in the y spot, that doesn't mean y-intercept. I notice a lot of you are doing that. When you see the 0 in the y, you think y-intercept. No, it's the opposite. When I see the 0 in the y, that's an x-intercept. When I see the 0 in the x spot, that is not the x-intercept. That's the y-intercept. So if you have to look at the 0 in order to figure out x and y, just remember it's the opposite. If you're looking at the number that it gives you to tell you its placement on that axis, then you're good. Whatever that number is and whatever spot it's in tells you where to put it. So if there's a 2 here, you go to the 2 on the y-axis. If there's a 2 here, you go to the 2 on the x-axis because it's in the x spot. So I can eliminate B and C because they say 2, 0. And 2, 0 is this point, which is not on the line. And D is on the line as well. So now I have to figure out, do the x values increase by 3 and y values decrease by 2? Or do the x values increase by 3 and the y values increase by 2? Okay, so I'm going to find 2 points on the line. Voila, 1, 2, and do my slope. So I'm going to rise. That means to go down 2. So I am decreasing by 2. 1, 2, 3. I went over 3. So I increased by 3. These are x values that are moving. See? 1, 1, 2, 3. My x values moved 3 times. My y values moved 1, 2. 2 times. So it would have to be A. It's A because it decreased 2 times for the y value and increased 3 times for the x value. Which table shows the same rate of change of y with respect to x as y equals 4 minus 5 over 8x? Okay, so rate of change means slope, so which one of these tables would have this same slope? You can go in and do your rate of change and try to figure out which table has negative 5 over 8, or since you have an equation, type it in the calculator and then hit Control T to look at a table to pick the answer. This is a freebie. This question, there's no reason to miss it. So calculator, 4 minus 5 divided by 8x. You can type it like that. Some of you want to use Control Divide and then put 5 and then 8 down here and then the x on the side. That's fine. But when you press enter, you get the graph, and you notice I didn't type the y in because that's f of x. So then after that, you hit Control T, And we find a table that matches. Well, this one says -4, so let me go up to the negatives, and it's a 6.5, okay? 2 is 2.75, it's a C, yes. 4 is 1.5, yes. And 8 is -1. We found it. It was a C. So that was a freebie. I'm going to stop this video, and then we will start on the next question on the next page on the next video. If I can find the stop button. Oh, there.